Hello Internet, this is Oleg and this is my tech review. Today's video is about continuation of 10 gigabit network testing at your house. So once you're gonna get it done and all the infrastructure is in place, we'll have to do some actual testing to confirm that your infrastructure is supporting 10 gig and it's actually running on 10 gig network. I was surprised to find out that my DL360 is not really capable of driving 10 gigabit network even though I have installed 10 gig card. The reason for that we're gonna discover in this video. Also, we're going to be doing some testing for the I/O throughput, which is also the main reason why you are configuring 10 gigabit network. You need to make sure your network supported, your storage supported, and for that we'll do some testing and benchmarks to validate that 10 gig is actually driven by 10 gig, and if you hit the limit of the throughput, that's the limit is actually from the end device and not on your network, and that you can improve going forward, especially if you're using NAS. Adding cache to the NAS is actually gonna help a lot to get your throughput higher and make your experience with 10 gigabit network much more satisfying. With that, let's start with overview of actual hardware which I have right now. I'll show you that, how the whole thing is configured and set up, both in physical hardware installation and in UNIFI. And after that, we're gonna do tests, and in conclusion, I'm gonna show you what to do to improve your throughput going forward. So let's start. Alright guys, so here's the infrastructure right now. As you can see, most of the links are actually white. That means they are connected to 10 gig. This is my SFPs. I didn't still connect a second SFP right now. It's still pending the actual port. I have to free it up on my Cisco. But the other infrastructure is all connected. So these are two going to one server, these are two going to another server. This is the actual connectivity to Synology, and this is going to ESXi server 3. So from the perspective of the connectivity, it's very simple. You have to get the actual SFPs, and they're not very expensive. I got those as a package, as a bag. You see the whole thing. I got it from eBay. I'm gonna link in the description down below how much it's costing there to get those. Those are 10 gig SFPs, and the cables are pretty cheap. I think I got like 3-meter cable for about $2 or something. So also you can purchase those on eBay even cheaper, or you can get them on Amazon. Alright, so from the back end it looks like the same pretty much as before. So this is how the connectivity looks on the back. So I have my 10 gig cards, and you see both ports are active. The reason for it, I'm using both ports to create a pipe, and then I'm cutting off from that pipe to actual data network and user network. And the same is going to another server, and the same is going to server 3 as well. This is the actual connectivity to Synology. It's only one port because I don't have right now any SSDs in that array. So there is no need to drive more in that throughput, and 10 gig should be more than enough to actually connect in and out. But main consumers right now, all the VMs are using this particular port right now to get all the data stores, and it's working pretty well. It's actually giving me throughput which I expect, similar to what you would see if the disk would be inside your ESXi host, and that's very, very impressive. Okay, let's go back to actual testing, and I'll show you the programs one by one. All the links are gonna be in the description, so you will see if you want to go to jump to specific timeline in the testing, then I'm gonna put those in the description as well, so you can go ahead and jump from one part of the video to another with very easy navigation through the timeline. How UNIFI Controller looks right now. I have my switch as well, so you see the number of switches increased as well. That's from the previous video. And we're gonna look on how it does actually report right now. So if you go to devices on your network, so this is my 16 gig switch, and as you can see right now, most of the ports are highlighted white, and I also named them. So some of the names are no longer valid, so I'll have to change those, but those actually will give you an idea what is connected to where. And this is my Synology NAS, and this is ESX host 1, and that is currently not Windows Pro, but actual ESX host as well. So we're gonna update that name, and it's easy to do. So just go like that, and you specify what you need to do. So it's gonna be ESX, actually 3, 10 GB, 10 gig network. – 4 A, apply, goes here. Second one, ESX3 10 GB port B. Okay, the reason you name these ports is actually to make sure that once you get everything is connected, it's much easier to find it once you get things in a name and you assign name to it, because sometimes you don't really remember what is connected to where, and go back to the data center and trace your cable is not really a good option. All you have to do is just do some prep, and once you get cables connected, just spend another maybe 1-2 minutes to update the names, and that way you're going to be okay. As you can see, I still have some ports available for the future expansions, but all of those ports which are primary ESX ports and also Synology NAS, they're all connected to 10 gig. So let's go back to the... Okay, so first thing what we're going to do is to actually go back and do file testing from my Synology NAS. That's going to my Windows VM, which is Windows 10. As you can see, I'm using the file, which is 12 gig in size almost, to just see how much the throughput we can get. And just for that, we're going to delete this file from my storage on flash. Just delete that. And we're going to copy it again from this guy over here. This is Synology NAS. The IP address is 10. That means for me that it's 10 gig network. It's got also normal IP address, which is just 1. And that would be 1 gig network. So let's go back, copy it again, and it says, yeah, some security warning, that's fine. And this is what we're gonna get. So 360 megabyte per second, which is, I think, average speed for the flash drives, unless you're using M2, and I don't use M2 over here. So these are okay, and this is also depends how fast you can read from that file on the NAS. And on NAS, like I said, I only have 8 drives in RAID 6 configuration, which are normal spinning drives, and I don't expect that much speed over like 300 or 400 gigabyte per second. I don't need that. I don't expect that to be over that number because it's just a spinning disks, and I don't have cache on that yet. So that's why it's also impacted on the performance right there. So if we're gonna copy back, let's copy back over here. And it's just gonna do pretty much similar speeds going backwards, and maybe a little even less, because like I said, the recording, the writing throughput on that Synology NAS is not very impressive in a way that it's only spinning disks right now, but it's still going like 300 megabyte per second on average, or maybe slightly less, which is okay for me, and that's fine for now, I guess, because once I get this Synology expanded to with a cache, then it's going to be much faster, I know that. So that's what we have right now, 300 megasecond, then 11 gig file took like 10 seconds to move, which is okay, I guess, on that particular network. So that's your normal file speed. If you're using big files and you're moving things around, that's very helpful. I don't still recommend using that approach to actually edit your videos off that NAS unless you have some direct attached, directly in that NAS you have cache like SSD drives, or you have M2 cache installed. Right now Synology cards are only going to be available, I think, going from New Year, when we're going to have 10 gig card. At the same time, it's going to be a slot for M2 on it as well. That will answer questions for most of the people who are using Synology, that you will have 10 gig capability, plus you're going to have cache as well. So I'm just waiting for that. Once I have it available, well, order those and update my cart on Synology. But for now, it is what it is. From VMware side, and you can see here I have VMs on ESX Server 3, and they're connected through 10 gig network. Also, the actual hard drive which is provisioned for that VM is going from NFS NAS 3 over 10 gig as well. So ideally, we would like to see the actual acceptable speeds on access and local storage for those VMs, to see if that's going to be similar to what you would have if the disk would be local to the actual VM. Alright, so for that we're going to switch to that VM 74 SRV. I have directory here which is called file test, and first thing we're going to do is we're going to do file test on that. So I have created scripts. Let's do that. File test, and we're going to have 8K block size. We're going to have file created of 10 gig, and we're going to do 2 of those files. So these VMs, most of the throughput is optimized for 8K blocks, so that's why we're testing with 8K. But overall, on average throughputs you're gonna get is the I/O going from anywhere from 8K to 256K. Smaller block size, you're gonna give you higher IOPS to get the same, because you have to do more work. But if you're gonna increase the block size, then you're gonna obviously have less IOPS, but it should still show you the pretty much identical throughput on what you have. But what I noticed is on my test over here, with that particular setup, the 8K block size give you slightly higher throughput than anything else, and 256 will give you actual slightly less throughput, and 64K would be somewhere in between. Alright, so let's get that test finished. It's gonna go 2 more seconds, 1 second, and here it is. Alright, now it's gonna clean up, but while it's doing that, I'm gonna show you the results. It's right here, right this line. So 46K IOPS with average throughput of 362 megabyte per second. 380 was the maximum. We actually saw that even higher than that slightly, and we moved 21.2 gig in that much milliseconds. So as you can see here, also what is important, that disk is driving pretty much on its own capacity, or its maximum capacity of the utilization, and it's 99.7. Let's do another test, and this way we're gonna go ahead with 64K block, 2 files again, 10 gig, and then we're gonna look what Synology NAS sees on the throughput for the network. Right, so that's test started. It's file test again with 64K. I'm gonna actually show you the file as well, the file which I'm using right now for the script. But file test is actually used right now mostly for management of the throughput of the devices on the network or on the fiber channel. Whatever it's gonna be, it's gonna show you that throughput. Very good numbers. So let's see what we see from the actual Synology. Yeah, like expected, 400 megabyte per second. That's what loaded right now on the Synology NAS, and it's driven mostly like 85% of CPU usage. But again, it also depends, that throughput is also depends on what is configuration of your Synology NAS. If you have SSD cache, that performance should be higher, because we can drive more on that. And it's gonna be, I'm gonna show you another test, which is actually gonna test the network cards themselves, what they can drive on the performance, and we will see that how that different from PCI version 1 or PCI version 3, PCI version 2, to see what kind of actual configuration you would need to keep in mind when you're installing the cards inside your system, so it will use proper generation of PCI. Alright, so again, 378 you can do is, because we're using only 1 jobs right now, it's actually going, you can read this line as well, but it's 378, 361 in same thing as before. 361, we have slightly like only 5.7K IOPS, and we still move exactly the same amount of storage. Here we go. So this Iozone test is going to use 64K blocks. It's going to create again, let's say 10 gig file, and it's going to use it 2 threads. So I'm going to create 2 files like that, and I'm going to delete the file at the end, so the file I don't have to clean up. Alright, so let's run that. Iozone test is slightly different. It's also available on the internet. It's freeware. You have to build it and compile it, especially if you run on Linux, which I am, and then you can run it. 320. Yeah, it's going up and down. Iozone approach is slightly different. It's using cache on the system as well. But sometimes it's actually direct I/O is much better than using cached I/O. You can see the throughput is less, 159, 370. It's going again, spiking up and down. Again, on that particular system right now, it's not going to be that much of the different, but on the big systems where we tested that, it's creating a lot of difference. So 396 is the maximum. Let's see the results. So as you can see, throughput which we have is on 2 children is 358 megabyte per second. So the files get deleted as far as I know. Yeah. Okay. Alright, so Iozone is another way to test these things and make sure you get throughput right now, but we want to also see that your actual throughput on the network card is driving 10 gig. And for that, you have to make sure that both systems which you're testing against are actually going to have 10 gig configured properly and the cards are in the right places. To monitor the actual placement of the cards when you have installed in your system, you have to make sure that you have proper PCI generation cards. So as you can see here on one of my VMs, I'm going to show you that for the difference. So if you place that in that particular slot, which I do have my 2 PCI cards, 48 lane port, like it's PCI Express and it's generation 3. That's very important. You have to get generation 3 to get proper speeds, which are giving you up to 8 gigatransfers per second. If you go down over here, you also see that my motherboard also have 8 ports right now, 8 lane cards with PCI Express Gen 2 ports. If I would have installed my card over here, that would have been only capable to 5 gigatransfer per second. So that's very important. So when you have to install your cards for 10 gigabit network, please make sure your chipset support that and you have cards in proper places if you have multiple PCI Express bridges like I do right now here. So you see here Intel Corporation, it's got these cards here on the C210 series chipset, and also I got another chipset here which is PEX chipset, right? And that's gonna give me a Gen 3 and Gen 2. From the Linux perspective, you can easily check that by doing lspci minus VVV, right? And it's gonna show you that your cards are capable. Right now here, see, link status aggregation. This is actually because of the VMs, but ideally if you have physical hardware, that should tell you that it's gonna be 8 over here, not 5. Alright, so and to test that, you can easily do this because we can check these file speeds from the 2 different machines right now. The software which you have to run is called iPERF. Pretty many people familiar with iPERF, but I'm using that and that's what I have right now. So if you go and specify that to IP address which I have for that machine is 29, then you will see that the links which I'm getting is slightly ramping up, 7.8, 8.1, 853 gig per second. And the maximum which we would get is probably close to 9. We're not going to get 10 per se, right? But at least from a megabyte perspective, we also get one. So eventually we're going to get 1 gigabyte per second transfer. And that's parallel transfers. You can see I have 8 parallel things going at the same time. Ideally, with iPERF, there are some gotchas which you have to run. If you have too many parallels, then the speed will go down. If you have too few parallels, then the speed will go down as well. So ideal number is somewhere between 8 and 12. And that's what I'm running right now. I'm running 8, right? So if I'm gonna get the same results going towards the system, which is on my HP server, which is quite old, and it's also only got Gen 2, so PCI Express. If I got that, okay, so let's run it again. I just restarted my server, and as you can see right now, the speed is going to be less. It's maximum I saw is like 2 to 3 gigabyte per second on this machine, which is kind of not ideal, but for the server, and since I'm not using it much from the IOPS perspective, that should be fine. But that just gives you an example how it is important, and it will actually drive your IOPS unless if you don't have the proper power and proper PCI cards inside your machine. See here, it's 1 gigabit per second mostly, and it's not going well. 163, and it's mostly driven also because it's the old HP server, but it's also because the IO card is placed in a slot which is, I think, only capable of 5 gigabyte maximum, gigabit per second maximum, and that's the way it is, right? So when I looked on that system, it doesn't even say on the chipset what PCI version it is, right? As you can see here, it says Intel Corporation 500 series chipset PCI Express for 4 lanes port, and that's what it is. And I also put it into 8 lanes right now over here. But if we go ahead and search for that Intel 500 series chip, you will see that it's a PCI Gen 2. So it's not capable of driving more. Plus, on that particular server, there is an overhead on that's generally everything is slower on that HPC. So the other thing which you can do is to validate that you're capable and connected to proper speeds is to actually run things like ls hardware. For example, on Linux, it will tell you my capacity on the network interface is 10 gigabyte per second. There is also validation if you have many interfaces going. For example, we're going to go ahead and use same interface right now on the Windows and just redirect it to use normal 1 gig. And you will see how slow it's going to get. So it's still a good way to validate your network in terms of connectivity and cabling integrity and everything like that. But let's go just set it up. And it's gonna. The reason I'm using -B is because I have multiple interfaces on this system, and I have to bind my test to any specific of the interfaces. Let's update the Windows right now over here. So for this, I have to specify the client is different, is 38. And that's gonna go to my Mac Pro. As you can see, the actual speed is only 940 megabyte per second, which is 1 gig, which is exactly what we expect, right? So 1 gigabit per second, it's not 1 gigabyte per second on the normal cable, it's 1 gigabit only, and that will translate to around 113, 112 megabytes per second. So that's what we're gonna have on the normal speed. And of course, file transfers are gonna be much higher in time because it's way slower than normal. Again, we can also check the iPERF for the previous connectivity like that. So if we do it again on the Linux system and start driving that, the throughput over here again is showing 8.9, but the most interesting part is going to be here on the network graph. You will see that it's driving gigabit per second, like 8.7 gigabit per second, which is exactly what this card is supposed to do. Alright, so when the speed goes, it's going like that. Then the speed test goes, but when the move files around, it's gonna go slower because my current NAS again doesn't have cache, and that's why the speed is gonna be impacted. But in general, first thing you do once you install the 10 gigabit cards, you run iPERF and validate that your infrastructure is running correctly, and you see like 8.79 gigabit per second at least on your tests, right? And it should be consistent, more or less. Like you see some dives here, but in general you should be around 8, above 8 at least, right? Just to see how that's going to be reacting on the file move, let's go back and move the file again. So I'm going to have my 11 gig, here it is. Copy it over, replace, and this thing will go like 3.3. Yeah, that's the maximum I can get for now from off my NAS over to this system. The interesting part would be probably to move something from another server. I have to get a Samba share created on the Linux and move it between the Linux machine and this machine on the Windows side to see if we're gonna get proper throughput on the files. So it's done almost, right? And it's dropped again. Okay, so that's the benefit of 10 gig. If you work in this 10 gig network, if you have proper throughput and you have proper caching set up on your NAS, and or your storage array is on flash, that's gonna be an overkill, but it's possible, some people using that, then you definitely can actually work off your 10 gigabit network and have your files always on NAS, protected and with RAID or whatever, right? And that way you can actually benefit from redundancy and from throughput at the same time. For NAS, to connect to proper system inside your house, you need at least Cat6 cable. My recommendation would be with Cat7 or Cat8. Depends on your length of the cable which you're going to use. And Cat6 you can actually do yourself. You can buy the cable online and just crump it with the crumper, but make sure you actually test it again after it's all validated before you start using that. If the distances are not that far and it is within the same floor, for example, my recommendation would be to just order cables like Cat7 on Amazon or eBay, get them sent over to you. They're going to be certified and ready for you to use. You don't have to hustle with those cables. Alright, that's all for now.
Okay guys, that's it for quick review today. Thank you for staying with me till the end. If you like this video, you know what to do. Give us a thumbs up, share it with your friends, subscribe to the channel if you're not subscribed yet, and make sure you actually follow the instructions and validate your 10 gig network as I describe it. If you have questions personally for me, you can put them in the comments down below and I will answer those. Until next tech review, I'll see you around. Peace.